Man, this calculus stuff we're learning about modeling and optimization is just so difficult, man. Gosh.
I don't understand a single thing. It's like I have to decipher a new language just to figure out what the heck is going on inside this book.
Taylor, your book's upside down.
It is?
Idiot.
Oh!
God.
Wait, I'm still confused.
Why?
Nothing makes sense.
Well, your book's right side up. Oh, we just have this calculus project, just don't understand what we're supposed to do. What problem we're supposed to do.
Dude, we should do number 46.
Number 4.
Alright, so this simple calc problem is we're talking about. It's Fermat's principle. Basically, it's stating that the angle of reflection or incidence of a light going into a mirror has to be equal to the angle of reflection on the other side. So we're going to prove that using calculus instead of simple geometry. Alright, so basically this is the drawing of Fermat's principle, basically the angle of incidence and then the angle of reflection. And so we have to prove that this is equal to that using calculus. So to show that theta 1 is equal to theta 2, we have to set these as triangles and make them triangles and then equate the two triangles to each other. Also realizing that light always tries to take the shortest path. So to do this, we can create the equations for the triangles, being that c minus x, which is this leg right here, divided by a, will be equivalent to x divided by b. So that's the first step. Now, what we need to do is we need to find L. And so L is going to be length 2 and length 1 together. So because we have to minimize the path length, we can make L equivalent to L1 plus L2. And then now we have to find what L1 and L2 are. So the way that we do this is using the Pythagorean theorem. So this is the answer for L1 and L2. But the way that we get this answer is we know that a squared plus b squared is equal to c squared. So if we replace c with L, we can then square root the other side of a squared plus b squared. Now we know that this a in the Pythagorean theorem is equal to c minus x, because that's one length, and then we can just substitute that in, and then a squared substituted in. And then L2 is the same exact thing with x and b. Now, now that we have this equation for length 1, we now have to find the derivative of the L of the length equation. So the derivative is 1/2 times parentheses negative 2c plus 2x all over the square root of c squared, blah, blah, blah. So basically how we got this is that the 1/2 comes forward from the square root, as you see right here. And then we know that that c is considered a constant, and the only variable within this radical is x. So whenever we find the derivative, we can then, the inside of it would only be equal to negative 2c plus 2x, as we would derive c for 0, since it is a constant, and then times negative 2c by deriving just the x out, plus 2x. And then all over the square root, because the negative 1/2, or it goes to a negative 1/2. And then when just simplifying it, it's just negative c plus x, because 1/2 times 2. And then length 2 is the same thing. We just normally derive it, and we reach to 1/2 times 2x all over the square root of x squared plus b squared, and then it just turns into normal x. So now we set that equal to 0, as seen here, and now we set them equal to each other by adding the c or negative c plus x over to the other side, thus changing the sign just to c squared minus 2c. Now, when we look at this, it looks kind of different. So after we moved it to the other side, we then just squared both sides to remove the radicals in the bottom. So we squared the top, which is c squared minus 2cx plus x squared, and then all over c squared minus 2cx plus x squared plus a squared equal, blah, blah, blah. So now this is where the fun happens, as you can see with the happy smiley face that we all are. Basically, we put this into, we cross multiply it all out, and we get this really, really long equation of them equal to each other. Now, after we have this really long equation out, we can see here that a lot of terms actually cancel out with each other. So c squared times x squared minus 2cx cubed plus x to the fourth plus obviously a squared times x squared on one side, and then c squared b times b squared minus 2cb squared x plus b squared x squared. Now we have to get all the terms onto one side. So when we move it over, this is what it is equal to, as equal to 0. And then we can actually take out an x squared here between these two terms and make it just x squared minus b squared times x squared plus 2cb squared x minus c squared b squared. And so set that equal to 0. Now we just have to plug this into the quadratic formula, and basically that'll give us the answer. So after plugging it into the quadratic formula, this is absolutely disgusting, as you can see. And yeah, I mean, it's absolutely beautiful, isn't it, Taylor?
You put it into the quadratic formula, you get x squared equals negative 2cb squared plus or minus the square root of 4c squared b squared plus 4 times a squared minus b squared times c squared times b squared, all over 2 times a squared minus b squared. Whenever you begin canceling out terms, you get x equals negative 2cb squared plus or minus the square root of 4a squared c squared b squared, all over 2 times a squared minus b squared. As you move further down the line, we'll just go ahead and skip that. You get negative 2bc times b minus a over 2 times a plus b times a minus b.
One thing to note with this is that we did not include the negative portion of the radical due to this needing to be positive, since length must be positive.
And this equation right here, let's get this out of here, cancels down to b times c over a plus b equals x. All right, over here, we take our answer of x and put it into our original equation of c minus x over a equals x over b, and then it becomes c minus bc over a plus b all over a equals bc over a plus b all over b, which then that cancels out to be c times a plus b all minus b times c all over a plus b equals ac over a plus b. This then becomes ca, or c times a plus c times b minus b times c equals ac, which then cancels out to ca times ac.
Therefore, the angle of incidence is equal to the angle of reflection using calculus.
I'm gonna walk outside with this.
Oh, it's a dud. You're a dud. I said that's a dud. You're a dud.
Oh,
Oh, what? We're good.
oh, this is
This is real warm. This is real warm. I love warm. You're a hobo. Ah!
That is.
I don't think we should be breathing this in.
No, you shouldn't be breathing this in. It's very unhealthy.
Can I light myself on? Wait, what if I put this in my mouth?
Guys, we need to increase series. We need a good percentage
Oh
of it.
god. Oh.
Guys, we need to get a good percentage of this. Oh gosh. There we go.
Oh, there's space of it in there.
Don't play with fire, kids.